Previously, we've looked at making and graphing cubed functions, functions that were in the form of f of x is equal to x cubed. Well, today we're going to change that up a little bit, and we're going to be looking at cube root functions. So our goal today says I can graph cube root functions. We start off real similar to what we did with our previous ones, where we have our table right here. I go in, I simplify my functions. I have f of negative 8 is equal to the cube root of negative 8. The cube root of negative 8 is negative 2. I do the same thing with negative 1. I plug it in. The cube root of negative 1 is negative 1. Cube root of 0 is going to be 0, and this would be 1 and 2 respectively. I go and graph these over here on my graph. I have negative 8, negative 2, so I go to the left 8, down 2 places. Negative 1, so left 1, down 1, going always starting at the origin. Here I have 0, 0, 1, 1, and 8, 2. And my graph looks like this. Coming along through here, a little curve in here, and through this way. Our cube root functions are all going to look real similar to this. The domain for these will be negative infinity to positive infinity, or you could also write it in set notation where you have x such that x is an element of all real numbers. Same thing with the range. The range will be from negative infinity to positive infinity, which is all real numbers again. And my center, which is also sometimes referred to as our point of inflection, will be located at 0, 0. That is this point right here, where we have the change in direction of the graph. If you notice that this compared to my cube function is basically like the same thing laid on its side. When we go on and start adding extra numbers into our parent function, it's going to take and create some transformations as well, just like we did with our cubic functions. So if I go and graph my parent function, we're going to graph it in blue, so it's easier to see here. Make the pen a little larger so we can see our points. We have negative 8 here, we have 1 there, here, here, and here, and the graph looks kind of like this. And this one is f of x is equal to the cube root of x. Now if I do the same thing, except I multiply by 4 this time, we'll graph it with the red pen so we can see what's happening. So here, if I put negative 8 in there, and the cube root of negative 8 would be times, it would be negative 2, and we multiply that by 4, that gives me negative 8. This one is going to be located at negative 4. 0 is still in the same spot. This one at positive 4, and this one up here at 8. So this one will look like this. Coming way down through here and out this way. This one is my f of x is equal to 4 times the cube root of x. Notice how it's been stretched vertically. If we take and do the 1/2, the 1/2 of this one, we'll do this one with the black pen, making it a little larger so we can see it easier. So half of 2 would be 8. Half of this one would be 1. 0 is still the same. This one here will be half here. Half of 1 is 1/2. Then here. So notice how this one is a lot flatter. and skinnier. This one would be my f of x equals 1/2 the cube root of x. So just like with our cubic functions, the cube root functions, when you multiply by a number on the outside, it's either going to stretch it or compress it. Now looking here at our next set of information, for these, putting my parent function here in blue again, so we get all the points located, placed in. I go and put all these here. Here's my parent function. This is f of x is equal to the cube root of x. For this one, we'll graph this one with red. We're going to be moving it 3 places up. So everything is exactly the same, just 3 places higher. So we'll have a point here, a point here, 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 and here. The graph looks exactly the same. It's just been shifted 3 places up. This one is my f of x is equal to the cube root of x plus 3. Also, if we do this one right here, which we'll do this one with the black pen, we're going to move it down 4 places. Every point gets moved down. 1, 2, 3, 4 places down. 1, 2, 3, 4. 4 places down for each of them. The graphs will all look identical without any stretches or changes. In that order, it's just a matter of its location being translated. Just like with the cubic functions, adding or subtracting a number will shift it up or down. My cube root functions will be like so. Cube root of x minus h plus k. A is what gives us our vertical stretch. Or compression. And then negative ones will result with a reflection. And then my center will always be h and k. Notice with these, the h, it's going to be opposite of whatever is in here. So if we have a minus 3, that becomes a positive 3 when I locate my center. Graphing cube root functions. Everything will be based off of our parent function, which is this one right here. And then we'll make some adjustments or shifts to it as need be. Enjoy.